You're listening to the Cyberwire Network, powered by N2K.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down the threats and vulnerabilities, solving some of the hard problems, and protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
We had actually all been in a training doing heap exploitation the week before this vulnerability was announced. And so as soon as we saw a major heap vulnerability come up, we all wanted to take a look and actually try to use what we had just learned and write this exploit.
That's Ryan, a security researcher at Bishop Fox. He asks that we not use his full name. The research we're discussing today is titled Building an Exploit for FortiGate Vulnerability CVE-2023-27997. Yeah, the timing is everything, right?
Yeah.
Well, let's walk through it together here. Can you take us through step by step? How did you and your colleagues approach this?
Yep. So initially, when we started looking into it, we just went and tried to follow the blog post that Lexfo, the original researchers, Charles Foll, published. So they have a really detailed write-up of all the steps that are required. And so we just tried to replicate that. So we started by setting up an environment with a vulnerable system, and I used Fortinet on an ESXi system just at home and figured out how to configure that, figured out, okay, I am able to hit this endpoint they're talking about, and then worked on just being able to get a crash proof of concept, because that, in theory, should be pretty easily. And then once we actually had a crash proof of concept, I worked on trying to get a debugging environment set up, meaning installing GDB, being able to have a root shell, because Fortinet appliances don't actually, they try not to let the user obtain a Linux shell. They don't even have a proper shell installed. If you run binsh, it won't drop you into a shell. So there's a process of setting up this debugging environment. And then once we had the debugging environment and we had something that could at least cause us to crash, then we could continue on with writing the rest of the exploit.
Well, let's back up just a little bit. I think, as you pointed out in the research here, that this bug is a heap-based buffer overflow. Can you describe that to us for folks who may not be familiar with that?
Yeah. So in most programs, you have two areas that you store data. One area is the stack, which is typically for temporary things. Maybe it's only used for the lifetime of a certain function. But if you want something that's kept around for a long time, or maybe you have a lot of data, you'll allocate in the heap. And so the heap is just a big area of memory, and you have a code that will manage this area, and you can request, okay, I would like 1,000 bytes, call a function, and it will return a pointer to an area where you can use 1,000 bytes. And then when you're done with that area, you say, okay, I no longer need it, free this area, and it can then be reused. And so with a Stack Overflow, there's a lot of other program state that is stored on the stack. And so if you're able to manipulate that, it can often be pretty easy and pretty deterministic how you would turn Stack Overflow into a full exploit. But on the heap, there is a lot of other stuff that is using it. It's a lot less deterministic, and there's a lot more work that needs to be done to manage the layout of the heap. And there's less program state that's directly usable to get code execution. There's often a lot more setup and crafting fake objects and a lot more really deep stuff that you have to do to actually get a successful exploit.
Well, walk us through, how did you trigger your first crash?
Yeah, so the actual bug relies on a difference between using two definitions of the size of the request that you're sending. So one definition is just the length of the request. It's a string, so it can check how long the string is. The other definition is that there's a size field embedded in this message that you're sending. It actually misinterprets the sizes. And so if you send it a message of one size, but then you set the length field to an extra 1,000 bytes, you can corrupt a bunch of data that's out of bounds of this buffer. And since it's on the heap, that can just be anything. There's some amount of manipulation you can do to make sure it crashes. Sometimes it won't crash. But if you just send a bunch of requests where the size field is longer than the actual length of the message, eventually you will overwrite something sensitive and cause the application to crash.
The start of the year is a great time to take that next step in your education, career, and beyond. Rely on N2K certification prep to provide the tools to help boost knowledge, skills, and confidence to get you there. And now, for a limited time, all N2K certification practice tests are 40% off. Visit n2k.com/certify and use promo code N2KVDAY. That's N2KVDAY to save 40% on your purchase. That's n2k.com/certify with promo code N2KVDAY. Offer ends Monday, February 19th. Happy learning.
And now a word from our sponsor, 6sense. 6sense provides award-winning cloud-based automated endpoint and vulnerability management solutions to streamline IT and security operations. With its advanced platform, businesses gain complete visibility and control over their infrastructure, reducing IT and security risks and optimizing operational efficiency. With 6sense, you'll get real-time alerts, risk-based vulnerability prioritization and remediations, and an intuitive automation and orchestration engine so you can focus on your core business goals, confident in the knowledge that your enterprise is secure, compliant, and running smoothly. Visit 6sense.com to learn why enterprises choose them. So you achieve your first crash here, then what do you set out to do next?
So once you're able to achieve a crash, you want to start to make this a more controllable crash. So instead of writing to some unknown area in the heap, you want to actually know that immediately after my buffer is some object where there's a field that would be useful to overwrite. So you try to set up the allocations and deallocations on the heap such that when you overflow your buffer and write data out of bounds, you are writing to something that you know, and you can overwrite in a much more controlled way. So instead of trying to generate a crash just by throwing random data, you want a crash where you actually know what you're doing, control what you're overwriting, and get a more controlled crash.
Are you able to read the heap ahead of time to sort of map out what exists in there and how it's being allocated?
No. So in this case, you would rely on knowing how the program works and understanding that even though it can feel non-deterministic, there is a level of determinism where you can control exactly which data you're sending and know that if I send this data, this will be the actual layout of the heap. So in this case, each time you make a request, there are 2 buffers that get allocated in this region that you're manipulating. And the first buffer is a structure that is set up for the SSL context, and the second buffer is a structure that contains your actual data. And through a bit of manipulation, you can swap that order so that you have your buffer followed by this SSL structure. And as long as you do your best to minimize any other noise and control the exact allocations that are occurring, you can make sure that you'll reliably have this layout.
What is your ultimate goal here in this exercise? What are you looking to achieve?
So the ultimate goal is remote code execution. And with this specific setup, there's a pointer in this SSL structure that is a code pointer. And you want to overwrite this function pointer so that when it gets called, it jumps to code and you can hijack that code flow and obtain and use it to then create a ROP chain and gain arbitrary code execution.
And so ultimately, how did you end up doing that? What were the rest of the steps that were necessary here?
So we use this function pointer to make a call to adjust the stack pointer to the beginning of the SSL structure. From there, we were able to have sort of complicated ROP chain that adjusted the stack pointer a few more times until it eventually pointed to data in our initial buffer, which we entirely control. From there, we could set up arguments for a call to system or popen or any other function. And we could use that to basically run arbitrary commands. And because, like I said earlier, Fortinet doesn't actually have a bin.sh or a shell, we were able to use the node binary. So it does use node for a web server. And we were able to create a reverse shell with node where we run node from exec. I believe we used exec-l specifically.
Now, help me understand here, because one of the things you point out in your research is that the heap was not mapped to be executable, so you had to get around that. Are there particular details you can highlight with that part of the process?
Yeah, so typically if you do have controlled writable and executable memory, you're able to just directly jump to that code. So instead of doing this complicated ROP chain, we would just set the function pointer to point to data that we control and execute it as code. But in this case, we have to do this more complicated setup where we point the stack pointer to data that we control. And then we're able to reuse different parts of the binary that is already in memory and executable. And we essentially run the last couple instructions of a function and then let it return. And then it'll jump to the next address on the stack, which we also control. And you keep doing that and building up these little ROP gadgets, these gadgets that do one small operation. And by combining a bunch of these gadgets where you're reusing code from the existing executable in memory, which is mapped as executable, you can actually still obtain arbitrary code execution.
What was it like for you and your colleagues when you ultimately achieved what you'd set out to do here? I mean, it sounds to me like this journey was fun. What was the payoff like in the end?
Yeah, so it's, of course, always exciting when you get that first connect back with your reverse shell. So I was very happy when I finally got that working. We were also able to actually create a scanner that we could use, and we released to help others identify what's vulnerable. And the payoff for the company was, of course, that we could go test on customer systems and say, hey, you're vulnerable, here's proof, and get people to patch. So there's really a lot of, for my team, it was mostly just really exciting, but for others, there was definitely a positive impact on their security awareness and posture.
Well, and based on the information that you gathered here, what are your recommendations for folks out there who are responsible for securing their organizations? Any words of wisdom to take away from this exercise?
Patch. Just make sure you're patching. I mean, this is an unauthenticated remote code execution. It is a heap vulnerability, but we were able to develop a working proof of concept within a week. No doubt other threat actors would be able to do the same. The fix is to patch your system, and please do that.
Our thanks to Ryan from Bishop Fox for joining us. The research is titled Building an Exploit for FortiGate Vulnerability CVE-2023-27997. We'll have a link in the show notes. And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show. The CyberWire Research Saturday podcast is a production of N2K Networks, proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. This episode was produced by Liz Irvin and senior producer Jennifer Iben. Our mixer is Elliot Peltzman, our executive editor is Peter Kilpie, and I'm Dave Bittner. Thanks for listening.